Oh, so let's run another case. So at the beginning, we set up this case, the 3D mesh. Now let's run again 2D mesh. I'm not going to repeat this setup. It is exactly the same setup, but just to show you that nothing changed, okay? So in this case, you can download the case file already set up, but also you can download the Fluent mesh and the settings there. So I'm not going through all the setup. So let me show you here that, see that I have the mesh, the settings, or I have already the setup initialized. So what I want to show you here, okay, I will run this one. Remember, this is 2D, put there 2D and start. So in particular, I will run this one using a uniform initialization. So remember that previously we used a non-uni for that vector. I will use the uniform just to show you that this one takes more time to unset the instability, okay? Because it is fully 3D, doesn't mean that it will run faster than the other ones at the same time, okay? So also I will disable the output. We don't need the output, so it might be a little bit faster this one, and I might be go also larger in the time step just to speed up things. So let me go here. I will read the case where I have all this set up, okay? So reading the case, you go here. So remember all this setup. Remember now it's transient. You have all the models, to boundary conditions, material, everything set up here. You have all the monitors. So let me initialize. Okay, and when you initialize, see that now you have here all these options. So see that I don't have any animations there. If I go also here, let me see that I don't have anything. I disable everything, so this one will be faster because I don't have this extra IO that sometimes tends to slow down things. So the first things that I want to show you now that we have this one, so it will be basically different between. So this is the initial. The initial initialization I have, everything uniform. In the previous case, I patch, okay, everything and add a perturbation just to speed up. So remember this here that you go here in regions, you create a regions, and then in that region you can add a small perturbation. In this case, I'm adding a perturbation in vector, so this is correspond to 5 degrees. Usually also small perturbation, 1-2 degrees is enough. So if you do like this and like this, you are patching these two fields with those values, and see that this is what I run in the previous case. So here you are just perturbating the flow, and you immediately will unset that vortex shading. But if you go like this, now see that if I select here initialization, okay, this one is different. This one you will have all the initial transient that it will take a long time. So I want to run this one first just to show you 2D is exactly the same. The difference now that we don't have the front and back patches, okay? So you see that you still have top, bottom, okay, with symmetry, the wall, okay, but you don't have the front and back, okay? And you will see also, for instance, if I want to visualize like the wall, for instance, at the cylinder, I want to visualize the pressure. Okay, let me set it here, cylinder. See that you have this line, so you need to, sometimes it's difficult to see that, so it's better to have that surface. The surface you can rotate and you see better. So that is my preference, that's why I like. But for the rest, nothing changed. So now that we have the uniform initialization, I will go here, I will increase, I have the monitors, I will increase the CFL to 1. This will be something equivalent to 10. The time set to 0.1 and will be a CFL of 10. Okay, is one you can compute the statistic. I don't need it, okay, if I just want to show you that it will take longer. And it's running to 100 seconds. And let me press now here, calculate, and off you go. So see that I start to do everything. We have all the predefined monitors. But what we want to see is just these monitors to see when we have the onset of this instability. So in the previous case was pretty much very fast. In 10 seconds, you already saw that. Let's see what happens here, how long it stays. So see that first, see that it's super fast. Now it's running fast. Okay, so let's see what happens here, okay? Okay, my case, I arrived to 100 seconds. So probably you realize that was faster because twice the time instead. But also we disable all this input output stuff. So we were saving time there in this IO. So look at the solution. We have all the monitors, everything set here. Okay, so here I already open another Fluent session. First, just to show you that to do the post-processing, the signal post-processing, you need to load a case. So see that I haven't loaded a case. I just open the file directly here. Okay, so you can use any file in the given format, or you have the Fluent format, or also you have a free file format. Okay, just the columns. But see that, just to show you a comparison between both. So now let me go here. So clearly you see here, let me see, let's see the signal, the here FFT. Okay, let's see the drag signal. Okay, it's the one that takes longer. But go here, load data, open, plot signal, apply, and let me show change axis. So this one, let me do 1505. Okay, plot. So look at the difference. So by just adding that perturbation, see that initial transit that you need to run the solution like 70 seconds up to the point that you can say that maybe here, okay, you have something that is statistically periodic. Now it starts to become periodic. Instead here, very fast already in 30 seconds, you can start to take statistics. So these are tricks, okay, techniques that you can use to speed up the convergence. I highly recommend you to do stuff like this. Always perturb the flow, but sometimes you cannot do it. Sometimes you want to measure this initial transit. So it's up to you. You know what you are doing. The way I show you, by changing the velocity vector, is not the only one. You can do it with pressure. Also, you can add perturbations in the initial conditions. So you can start the simulation. Remember that you can stop the simulation at any point and change any of this value. So for instance, you can start the simulation with a velocity, let's say, of 2, run like this for probably 2 seconds, and then after 2 seconds, stop and go back to 1, and this will add a perturbation and it will unset that. So there are many ways to add the perturbations. The most sophisticated one is doing like numerical tripwires, like what is done in experiments. So in a point in the domain, you can add a momentum, and that momentum will kind of blow some wind there to perturbation. So there are many techniques, but I don't want to show you that. So see that here you have all the signals, and clearly you can see that perturbation, that it takes a long time to unset that instability. The post-processing, now that we have a solution, is exactly the same, nothing changed. Okay, so for instance, if I go here, and if look at that, if you want to see the pressure contour in the surface, see that you get this line. So it's not easy to visualize that. Instead, having the 3D surface is easier. So for instance, I go now to this here, and I want to see in turbulence the y wall y plus. It's also trickier to see the value. So when you have that 3D surface, that extrusion is much easier to visualize, but it's pretty much exactly the same. Nothing changed. All your post-processing, vectors, path line, everything will be the same. The FFT here works the same in 2D, 3D, nothing changed. Okay, so at this point, I think this is all. We have covered the basics in Fluent, certain geometry, certain cases on steady, and also covered in turbulence. So for the next tutorials, okay, now we're going to focus more in the turbulence. I'm not going to revisit these concepts, okay, so you can go back to these videos. But okay, this is all. So we're missing another video that I'm going to show you how to use Ensight. So in this case, I already saved the data, so it's here. You can download Ensight data. Okay, so remember that you can set up here also in calculation activities and save. Okay, you can save with a frequency, given frequency, the Fluent data, but also here export it into Ensight, and you can set animations. Everything is exactly the same. So that's all for this case. Thank you for your attention, and see you next video. Bye.